purpose of this video is to help you make notes for the transition elements study pack. There are lots of key properties and concepts to do with transition elements, and they're quite a large part of the syllabus. And we're going to work through these in turn. At GCSE, you were taught to label up a periodic table and identify where the transition elements were. At GCSE, you'd have looked at the top row of that block in the middle and said, oh yes, they're the transition elements. At A level, we have labelled this block the D block. And we need to think what elements labelled as D block elements. What does that mean? Well, elements that are D block have electrons. The highest energy electrons are in the D subshell, or the highest energy electrons are in D orbitals. So, all of these, when we write the electronic configurations, we'll find that the last thing that we write is going to be D something or other. These, however, are not all transition elements. What we're going to learn is that the elements scandium and zinc are not transition elements. The ones between titanium and copper are transition elements. So we've got to be able to use the terms transition element and D block element accurately. So you're going to need a periodic table to help you do some of the exercises in the study pack. If you haven't got one, pause the video now, go and get one. Okay, so what I would like you to do is write out the electronic configurations of the elements titanium, manganese, iron and zinc. And hopefully what you've remembered is that when we're putting electrons around the atom, we put electrons into the 4s subshell before the 3d subshell. So if you need to pause the video whilst you write out the electronic configurations, please do that now. Okay, so what you should have done, nice and simply, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, it's going to be the same for titanium, manganese, iron and zinc. We'll get to 4s2, and then we need to look at our periodic table. Titanium is the second element in D block, so 3d2. Manganese will be 4s2, 3d5. Iron 4s2, 3d6. And zinc 4s2, 3d10. Right at the end. Interestingly, there are two elements that do not follow this pattern, and you need to absolutely be clear about these two elements. And these are chromium and copper, as we can see. So, when we first start writing out the electronic configurations, everything goes exactly as it should do. 1s2, 2s2, 2p6, 3s2, 3p6. Somewhat interestingly, what you would expect is 4s2, 3d4, but what you actually get is 4s1, 3d5. Similarly, copper, what you would expect will be 4s2, 3d9, what you actually get is 4s1, 3d10. And the examiners expect you to know about those two anomalies. It could be a very, very simple multiple choice question, it could be part of a much longer question as well. So, learn the anomalous electronic configurations of chromium and copper 4s1 for both, and then either 3d5 for chromium or 3d10 for copper. What we now need to think about is what makes an element a transition element. While transition elements have some very, very interesting properties, they are able to form more than one oxidation state for the element in its compound form. So we're not talking about the actual element as the element, but when it's in a compound, we've got variable oxidation states. So when we think about iron, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3p6, when we turn iron into the 2+ ion, one of the rules we have to remember is, although we put electrons into 4s before 3d, we also take electrons out of 4s before the 3d. So the iron will lose the 4s2 electrons. So after 3p6, it would just be 3d6. The 4s2 electrons have gone. It's very, very easy for iron 2+ to turn into iron 3+, because after the 3p6, we then lose one of the electrons from the 3d subshell, turning it into 3d5. So Fe2+, into 3p6, 3d6, Fe3+, 3p6, 3d5. So it can form two different ions in compounds. So that concept of variable oxidation state, variable oxidation. One of the things that many of you have remembered from GCSE, hopefully, is the idea that transition elements form coloured, very, very coloured compounds, higher coloured compounds, and that's one of the things we're going to look at in this topic. And you also hopefully learned about the catalytic behaviour of transition elements. Remembering the dreaded Haber process, some of you may recall that iron is used as the catalyst in the production of ammonia. Manganese dioxide, probably biologists may be aware of this, is a catalyst for the decomposition of hydrogen peroxide, and also vanadium pentoxide, B2O5, is something in the contact process which is used to make sulfuric acid. And being aware of a couple of examples is really, really useful. Now, what is a transition element? It's a key definition that you are absolutely going to need to learn. It's a D-block element that forms at least one ion with a partially filled D subshell. I can't emphasize to you how important definitions are in this part of the syllabus. The possibility of writing an A-level paper where that definition isn't somehow tested would result in quite a poor A-level paper. So D-block element that forms at least one ion with a partially filled D subshell. That is what the definition of transition element is. And as we've already mentioned, scandium and zinc are not transition elements. So they're not going to do that. That's what we're going to look at. Okay, we've got an exam question. Before you answer this exam question, what I want you to do is pause the video that you're currently watching, and I want you to watch the video. Follow the QR code, it'll take you to a Macam Guy video. Macam Guy will go through some of the properties of transition elements, and he will go through this idea that scandium and zinc somehow are not transition elements, but are D-block elements. So watch the video, and then what I need you to do is come back and answer this exam question. So pause this video, go and watch a different video, and then answer the exam question. Okay, so by now you should have watched the video. If you haven't, stop this one, go back and watch the video. Stop trying to jump ahead. So you should have watched the video, you've answered the exam question, you've got your answer, and we're going to look at what is it that makes an element a D-block element, what is it that makes an element a transition element, and can we explain why some D-block elements, scandium and zinc, are not transition elements. And we must use electronic configurations to support our explanation. So you should have your answer there, whatever that looks like. And now I'm going to model an answer for you. So first of all, we need to think, what is a D block element? Well, as we know, highest energy electrons are in the D subshell. If you said highest energy electrons are in the D orbital, that's quite acceptable. Transition element is an element that forms an ion with a partially filled D subshell. Oh, there it is. D block element that forms at least one ion with a partially filled D subshell. So we've got two key definitions. Please don't walk into your airline and not be clear about those two definitions. That is a recipe for disaster. So are we able to give an electronic configuration of an element that is both D block and transition element? We could choose iron, for example. We know that iron 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. We went through this earlier, didn't we? That's iron as the element. Iron, when it is in a 2 plus oxidation state, 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. 4s electrons have been removed. So we've got an element which is D block. It's an element whose highest energy electrons are in the D subshell, and it forms an ion with a partially filled D subshell. There are 6 electrons in the D subshell. That will be a good example to use. You can use anything really across that D block, apart from the elements that are not transition elements. So we need to think about some electronic configurations for these. Zinc, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. The only ion that zinc can form is the zinc 2 plus ion. It doesn't form any other type of ion. It's not like iron or chromium where there are variable oxidation states for the compounds. Zinc only forms the zinc 2 plus ion. And as we know, the electrons that we need to lose are the electrons from the 4s subshell. So zinc is not a transition element because it has a complete D subshell. So not transition element. We've used electronic configuration to show why it is not a transition element. When we look at scandium, the electronic configuration of scandium ends in 4s2, 3d1. And when we look at types of ions that scandium forms, it loses the 2 electrons from the 4s subshell, and it also loses 3d1 electron. There are no electrons in the D subshell. It's an empty D subshell. Remember, when we think about the definition of transition element, then what we're interested in is this idea about partially filled D subshells. If there are no electrons in it, it's not partially filled. If it's complete, it's filled, well, it's not partially filled then, is it? So scandium and zinc are not transition elements, but they are D block elements because the atom has electrons in the D subshell. If you look at the mark scheme, it's not a question. What absolute gift? To get up to 5 or 6 marks, you've got to define what you mean by D block element, define what you mean by transition element, explain why not all D block elements are transition elements. So I would encourage you to give an electronic configuration of an element which is D block and transition element and explain why it is both. And then you absolutely must be able to explain why scandium is not a transition element and why zinc is not a transition element. Okay, that's the end of this first video. The next video is going to look at ligands and the formation of complex ions.